Buyurun.
Okay, hello everybody and welcome to this seminar. I'm Rahim, graduated from Sabancı University in 2015. I have worked on sentiment analysis, especially on Turkish, during my PhD, and during the next 45 to 60 minutes, I'm going to talk about the challenges, resources, and techniques of this area. This is the table of content. We will define sentiment analysis, then we will talk about its applications. Then we will go through the challenges, which include granularity levels in sentiment analysis and language issues in this area. Then we will go over the resources, especially on polarity lexicons. Actually, I will not introduce all polarity lexicons in Turkish, but the largest one, which is one of the outcomes of the outcomes of my PhD thesis. Then I will go over the techniques, which are threefold: rule-based techniques, classic machine learning, and deep learning. Okay, let's define what is sentiment analysis. In the simplest case, sentiment analysis is the task of extracting polarity from data. This extraction can be automatic or semi-automatic. What we mean by polarity is positivity, negativity, or neutrality. In terms of data, people usually work on textual data, while other types of data can be imagined. Take this example. This is a very simple example. Sarah likes this hotel. She is more interested in its food. Here, opinion holder is Sarah. The polarity of Sarah towards the target is positive because of this likes, and the target is hotel. But in the second sentence, the aspect of this target is food. You know, hotel has several aspects such as room size, price, food, service, view, etc. And here only the food aspect have been appeared. Again, the polarity of Sarah towards this aspect is positive. And absolutely, we are in the hotel domain, while other domains such as camera domain, cell phone domain, movie domain, etc. can be imagined. Okay, then we are going to define some terminology. Subjective. Actually, subjective sentences are those sentences that contain the opinions of people. For example, if I say I like Ishik University, this is my opinion. This is my sentiment towards Ishik University. But in contrast, objective sentences actually are facts, or they are factual information. If I say Ishik University is located in Shila, this is not my opinion. This is a fact. This is a factual information in real world. But the interesting thing is that not always objective sentences bear sentiment. For example, take this example. Take this sentence. I want to buy a camera that takes good photos. Here there are positive words such as good, but actually, the sentences are subjective, but actually it doesn't have any polarity or sentiment. On the other hand, to be objective doesn't necessarily mean to have no sentiment. Take this example. My laptop stopped working 2 days after I bought it. You don't see any positive or negative words here, but actually the attitude of the author is negative towards the laptop. Again, we are in terminology. Emotion. Emotions actually are our internal feelings, which last from seconds to minutes. The basic emotions are anger, sadness, joy, fear, etc. Mood is similar to emotion, but mood lasts from minutes to hours. We may feel cheerful, gloomy, depressed, etc. And internal stances actually are our feelings towards other people. How do we behave towards other people? We may behave friendly, we may behave coldly, warmly, supportive, etc. And finally, attitude is the most similar topic, to most similar word to sentiment. Attitudes are our position or our actually feeling towards a target. We may love something, we may like it, we may feel neutral about it, we may dislike it, or we may hate it. Each one of these are equivalent to, let's say, very positive, positive, objective, um, pos negative, and very negative. Let's go over the applications and the motivation. So why do we study sentiment analysis? This is an important question. First of all, companies are interested in customers' ideas. When people stay at hotel, the guests can write their ideas about their stay while exiting the hotel, and these reviews have been collected in a dataset by the name of TripAdvisor dataset, which is publicly available on internet. On the other hand, customers themselves are interested in other customers' ideas. As an example, when we want to buy a product from Amazon.com, we may look at the ideas of other people written under the product to decide if we are interested to buy this product or not. And thirdly, policymakers and politicians are interested in public feedback. Here, Twitter can be a good resource. As an example, when I was at Sabancı University, I remember that one of the political parties came to our university and asked our research group to extract the public opinion towards their party from Twitter, and they wanted to know the public feedback towards their party, and we extracted tweets and analyzed them in terms of polarity and topic. This is another reason for studying sentiment analysis. This diagram has two lines, one is black and the other one is blue. The black line actually is a real Gallup poll which shows the satisfaction level of customers towards a company. But the blue line is the estimated satisfaction of those customers based on their tweets on Twitter. As you see, two graphs are very similar. So we can estimate the satisfaction level of customers about towards a product or company using their tweets on Twitter. Now let's go over the challenges. This part is very important actually and challenging. I will mention several challenges in sentiment analysis, but actually I will not give the solutions for all of them. Actually, some of them are open problems, as I myself don't know the exact solution for those challenges. But I will give some papers. I will refer the interested auditors to those papers to look at the solutions provided by several researchers. Let's see what group the Turkish language is located. Turkish language is located in agglutinative languages. The key aspect of agglutinative languages is that new words can be created by adding suffixes to the end of words. There are other languages in this group such as Finnish, Korean, Japanese, etc. Therefore, this key aspect makes analyzing these languages very difficult. As an example, this is only one word. You see, this is the root word, and in another point is that in agglutinative languages, the root of the word never disappear. This is the root of the verb. Then lam have been added as an suffix, as a suffix. Then sağlamlaştırabilecek is only one word by adding several suffixes to the root word. This word can be translated to English by 9 words. Actually, as you see, one word has been translated to 9 words in English. So there are other challenges in agglutinative languages that make analyzing these kind of languages difficult. Again, let's go back to our granularity levels. We start from the finest grained and go to the coarsest grained. We can work on word level in which we try to estimate the polarity of a word. This goal can be achieved by using polarity lexicons. We may work on aspect level to estimate the polarity of the aspects. We may work on phrase level, which is more difficult. We may work on sentence level or documents levels, in which we try to estimate the polarity of sentence or document. A word level. If our words have consistent polarity, analyzing them is very easy. For example, the word güzel or its translation in other languages is always positive. But the life is not always this easy. We have cultural dependent polarity words such as these words. Atatürk, Cami or Tanrı. These words have positive polarity in Turkish culture, but they may not have positive polarity in other languages or other cultures or countries. As an example, I have checked the polarity of the word God in Sentiknet. Sentiknet actually is one of the well-known polarity lexicon which has been created in England, and I found that the polarity of God is neutral in Sentiknet. The third group is domain-dependent polarity words. Some words may have positive polarity in some domains, but negative polarity in other domains. As you see, büyük or big can be a positive word for the aspect room size in hotel domain, while it has a negative polarity for the aspect battery size in camera domain. And these actually issues make word level sentiment analysis more difficult. The next level is phrase level. We have two groups of phrases, compositional phrases and non-compositional phrases. Compositional phrases are easier to analyze. In these phrases, the polarity of the phrase can be estimated based on the polarity of its constituents. For example, here iyi indicates the positive polarity of this phrase, but in non-compositional phrases, the meaning or the polarity cannot be estimated based on its constituents. As an example, göz boyamak or to deceive in Turkish has no polar words, no positive or negative words exist here, but actually it has a negative polarity. Next level is aspect level. Aspects are different actually facets of a domain, let's say. Here, for example, oyunculuk or acting is an aspect, effects also is an aspect, but the first aspect has positive polarity due to this polar word, and the next aspect has negative polarity due to the second polar word. Analyzing, aspect level sentiment analysis is twofold. The first step is to specify the aspect and target. The second step is to determine and find the related polar words to each one of these aspects. For example, here iyi is not related to effektler but related to oyunculuk. And extracting these related words can be achieved by some methods such as dependency parse tree or attention mechanism. For example, in my PhD thesis, I proposed these two formulas which get benefits from dependency parse tree to find the related words and calculate their average positive and negative polarity and assign these average polarities to the aspect word. Another issue in aspects is that aspects can be explicitly appeared in a sentence, but sometimes they are implicit. Here, for example, the aspect is food and it has been explicitly appeared in the sentence, the polarity of which is positive, but in this next example, the aspect is implicit. As you see, the aspect is price, but there is no word like price here. And because of this expensive, we determine that this word is related to aspect price. Sentence and document level sentiment analysis granularity levels actually try to estimate the polarity of a sentence. Sentences can be very easy, such as I like university, but they may be also more difficult, such as this one. Ben beğendim ama herkes beğenmedi. You see there are two parts. One part is positive and the other part is negative. And these issues really make sentiment analysis more difficult. Here we may say the polarity of this sentence is combined, combinational, or we may assign the polarity of the behavior part to the sentence. Documents usually contain more than one sentence. Here the first sentence actually is a little bit easy to analyze, but the second one is not that easy. Look at the second sentence. It is about a film review, movie review. 5 puan verdim. O da John Stone'un güzel yüzünün hatırına. So here we see a positive word such as güzel, but actually the polarity of the sentence is a negative. The author is not satisfied of the movie and he has given 5 points out of 10 only because of the lovely character of John Stone. The approaches for document level sentiment analysis can be bag of words, in which we have a bag including several words, let's say W1, W2, W3, etc. Here there is no order between words. The second approach can be bag of sentences. We may analyze each sentence in isolation and then assign the overall polarity of the sentences, or let's say the weighted average of the weighted average polarity of the sentences to the document. Another approach can be ordered set of sentences, which has more information. I mean, it has the order of sentences. The advantage of this approach is that we can assign higher rates to first and last sentences. You know, actually, people write their ideas more clearly in the first and last sentences. And this has been proved in the literature. The last group of approaches, which is the newest one and the most powerful one in the deep learning, is deep learning. In this group of approaches, usually people use higher level representation methods such as word embedding, sentence embedding, or document embeddings. The next group of challenges is language issues in sentiment analysis. I will talk about only these challenges, while a few other challenges also exist. The first one is negation. If negators appear in the sentence, they can actually switch the polarity of a sentence from positive to negative, or vice versa. Sometimes the sentences are very easy to analyze in terms of negation, such as this one. Pişman değilim. Here değil is a negator, which transforms the negative polarity of pişman to positive. But sometimes our sentences are much more difficult, much more complicated, such as this one. Take this example. İzlettiğim onca insandan sevmedim diyen çıkmadı. You see, sev here is positive. Sevmedim, medim makes it negative. Again, due to this word çıkmadı, the negative polarity of sevmedim turns to positive. We have to actually cover all these negation marks and extract the overall polarity of the sentence. The next issue is rhetorical questions. In these questions, actually, this is the example. In these questions, we do not ask question to get an answer. We just ask the question to convey a message. In this example, let's say if someone asks you Titanic'i sever misin, you may answer sevmez miyim. Here you see it's a bit complicated. Sevmez is negative, but sevmez miyim makes it positive. Actually, this is a rhetorical question, which means that absolutely I will like or love Titanic. This is another issue actually that should be covered for sentiment analysis. But actually this issue is one of the open problems. It has not been completely solved. Another issue is conditional sentences. In these sentences, if the circumstance or condition exists, the sentiment of the sentence will be true. Otherwise, it will be false. Take this example. Çok uzun olmasaydı sevecektim. You know, if the sentiment analysis system is a weak one, it will assign the positive polarity for this sentence because of this sevecektim or sev. But actually the author says that because it is too long, I couldn't actually I didn't like it, and the overall polarity is negative. Another issue is conjunctions. You know, the interesting idea which was proposed by Hatsi Vasiloğlu long time ago is that adjectives with the same polarity are usually conjoined with and or va and adjectives with opposite polarity are usually conjoined with ama or but. Look at this example. Film güzel ama çok uzun. And another example, film güzel ve heyecanlı. You see, these are two positive adjectives, but in the first example, due to this but word, the first one is positive and the second one is negative. This this simple technique can help us extract new polar adjectives from internet or corpuses, big corpuses. This also holds in other languages such as English. If we search this expression, was nice and something, you see here something is supposed to be a positive adjective. As you see, helpful and classy, which are two positive adjectives, have been appeared. So using this method, we may generate two clusters. The first one is one of them is positive and the other one negative. You see, these green lines are actually represent our and conjunctions, and the red lines are our but conjunctions. Another issue is emoticons. Emoticons actually are very simple to cover, but they are good indicators of polarity. If we see an emoticon at the end of a sentence, if the emoticon is positive, the sentence is most probably positive, such as this example. Vakit geçirmek için fena değil. It may be a little bit difficult to estimate the polarity of this sentence, but actually this positive or smiley emoticon indicates its positive polarity. But in the second sentence, ama daha fazlası yok, and a sad emoticon at the end of sentence indicates that the sentence is negative. Another issue is domain-dependent indicative keywords. Actually, these keywords are dependent to some domains. For example, in movie domain, if we see any one of these keywords or key phrases, we immediately indicate the positive polarity of a movie review, such as izleyin, izlenmeli, izlenebilir, iyi seyirler, or etc. But this one might be domain independent. Tavsiye ederim. Another issue is sarcasm or sarcasm detection, which is also one of the most difficult issues in sentiment analysis or NLP. In this issue, actually, the author writes many negative sentences. At the end of all these sentences, it writes only one positive sentence, but actually it sneers the target. He is not satisfied of the target. Take this example: the battery stopped working 3 days after I bought it. The resolution is now very low, and a few other negative sentences. At the end, the author writes, "Good job, Samsung." Actually, he is not satisfied of Samsung. This is a sarcastic sentence, and covering and analyzing these sentences is a difficult task in NLP and sentiment analysis. For some of these issues, I have given papers in which a partial solution have been proposed for each one of these issues. And due to time limits and the scope of this presentation, I couldn't explain the solutions for all these issues. The last issue is common sense knowledge. We as human beings have common sense knowledge, which has been collected from since our childhood to now. But the computer or the system doesn't have this knowledge. Take this example: one of those rare movies that makes me feel like I am there. The feeling that makes me feel, the feeling that I am inside the movie is a positive characteristic for the movie, because it is so real that I feel that I am inside the movie. But actually, the sentiment analysis system doesn't have this knowledge and cannot estimate the positive polarity for this sentence. But we as human beings can understand that this sentence is positive and the attitude of author is positive. Another negative example which includes common sense knowledge is: my cell phone stopped working 3 days after I bought it. There is no negative word here, but the overall polarity of the sentence towards the cell phone is negative. Okay, now we are done with challenges. We are going to introduce some sentiment analysis related tasks. The simplest task is polarity classification, in which we try to estimate the polarity of a target, and we can actually extract the opinion holder here. In this example, Aras has a dog. Aras likes him very much. Aras is the opinion holder, as I already explained. A similar sentence. The polarity or sentiment is positive. The target is dog. The labels here can be 5 labels, such as very negative, negative, neutral, positive, very positive, or this problem can be approached as a regression problem. Some people prefer the first one, and some people prefer the second. Another task is temporal opinion mining. In this task, actually, we try to analyze the opinions or sentiment of people during the time. And here, Twitter is a very good resource. And in this diagram, for example, starting from January 1, 2020 until March 6, 2020, people have written several tweets on weather, news, and coronavirus, but the number of coronavirus tweets has been drastically increased after some months. I mean, in the first month of 2020, and now we can analyze the attitude or feelings of people towards a topic or target based on their tweets posted on Twitter. As an example, I and my students have recently worked on a project which extracts the hot topics from Twitter towards coronavirus. And the name of the paper, which is publicly available on internet, is Clustering Clust, a communicative text clustering approach to topic detection on streaming data. We have done a topic detection, but in the second version of this paper, we are going to also apply sentiment analysis or emotion analysis on the extracted topics. Another interesting task is emotion analysis. Here, instead of sentiments or polarity, we try to extract the emotion from data. This comprehensive table shows the combination of emotions. In the colorful columns, the basic emotions have been written, but in the white columns, actually, the concepts which include the basic emotions have been written. As an example, if we have the feeling of hate, it means that we have the basic feelings of disgust and sadness. Or if we feel hopeful, if we have hope, we have joy and expectation. Or if we get shocked, we have anger and surprise. Or we have feeling of alarm, we have fear and surprise, etc. As you see, this table, which is proposed by Eric Camberia, one of the pioneers of emotion analysis, is an interesting table. And in this field, we have to combine computer science with psychology. The next task is multimodal sentiment analysis, in which we do not work only on text, but another types of data such as image, audio, or video also should be analyzed. For example, our features extracted from data can be face gestures, body movements, and so on. And here, various features from different domains or different data sources can be mapped to a shared latent space. For example, in an interview, when the interviewee is asked a question, if he or she looks upside while answering, probably he or she tries to give a fake answer or lie to the interviewer. And these techniques can be used for estimating the truth in interviews, or other applications are imagined for this task. Okay, let's look at the resources. On Turkish. There are some polarity lexicons in Turkish, but to the best of my knowledge, Senti Turknet is the largest one, and this resource is one of the outcomes of my PhD thesis, which includes 15,000 entries. It has been created based on Turkish WordNet. In this resource, actually, I have semi-automatically assigned 3 polarity scores, such as, namely negativity, objectivity, and positivity to each scene set in Turkish WordNet. And the version of WordNet that we used is the one that was created by Kemalov Lazer. One of the example scene sets is Allahsızlık in this resource. It has only one synonym. As you may know, each scene set or synonym set has several words which are synonyms. Here our resource says that Allahsızlık is 50% negative, 43% neutral, and 6% positive. And this resource has been mapped to English WordNet and consequently CentiWordNet. CentiWordNet is similar to CentiTurkNet, which assigns 3 polarity scores to each English WordNet scene sets. This is another example data entry from CentiTurkNet, which shows the scene set Cuma namazı. I have chosen religious or political examples from CentiTurkNet to show the culture differences or the differences between languages or countries. This topic actually has been labeled by a positive label, and its hypernym is also hypernym actually is the superclass scene set of a given scene set. This is its class is its explanation in natural language. Then we have assigned a part of a speech tag to each scene set. Actually, these fields already exist in Turkish WordNet. The label of this scene set is positive. Its hypername is also positive, but there is no antonym for it. And the equivalent English scene set of this topic is Salat, Salah, this one actually. And the numerical values that our resource has been assigned to this scene set is given in the second table. You see, these values have been assigned by CentiTurkNet to this topic, but these values have been assigned to its equivalent English scene set by CentiWordNet. As you see, CentiWordNet supposes Salat as a neutral topic, but CentiTurkNet supposes that Cuma namazı is 49% positive, 44% neutral, and 6% negative. The other numbers here have been assigned by different classifiers. I have used several classifiers, namely neural networks, logistic regression, and SMO. And finally, I have combined them to obtain a better result, which is given in the last row. So as I said, I introduced only one polarity lexicon, while there are other polarity lexicons. Some of them are not public, but out of those that have been made publicly available, I think, to the best of my knowledge, this is the largest one. In terms of techniques, I am going to explain 3 groups of techniques: rule-based, classic machine learning, and deep learning. In rule-based techniques, actually, we have to design rules with high accuracy to estimate the polarity of, let's say, a text, or estimate its class. This is a very simple rule. As you see, if we can say if the number of positive words in a text is higher than the number of negative words, then assign a positive polarity to the review or text. But the problem here is that maintaining these rules is expensive. This is one of the very important disadvantages of rule-based techniques. Before going over the other techniques, I'm going to give the text representation models. The simplest model or method, as I already mentioned, is bag of words. Its disadvantages is that it ignores word order, and it cannot completely carry the semantic of the word. In contrast, we may use bag of words, which partially carries the semantic of word, or it can actually keep the word order in some way, but not completely. Word embedding is the most complete method for representing the words, which will be explained in more details in the next slides. Um, I'm going to give a taxonomy for sentiment analysis techniques. Actually, there are two major groups: machine learning based groups and lexicon based groups. The group techniques in machine learning group will be explained more in the next slides, and I slightly will explain the dictionary based or corpus based approaches. In lexicon based approaches, we use syntactic relations in dictionary based or semantic relations in corpus based approaches. For example, synonymy or antonymy can be used for dictionary based approaches, and the conjunctions that I already mentioned can be used in corpus based approaches. This is a more detailed hierarchy. We are more interested in this part, in machine learning based approaches. As you may know, machine learning approaches can be divided into three groups: supervised, unsupervised, and semi-supervised. And each one of these can be divided into several methods that I'm not going to explain all of these in detail. The next hierarchy shows that deep learning techniques can be also placed in this group, which can be supervised, semi-supervised, or unsupervised. And it includes several methods, several well-known methods such as convolutional neural networks, recurrent neural networks, recursive neural networks, and a few others. In classic machine learning, which has been used in my thesis, actually we have three steps. In the first step, we pre-process the data to make it clean to be used in the next step, which is extracting features and applying a classification or regression system on our data. After cleaning our data or pre-processing it, we extract handcrafted features from data. Then we feed these handcrafted features to a machine learning system, let's say classification or regression, to train it and use it in the test set for estimating the polarity of unseen data. What I mean by handcrafted features can be these simple features such as number of positive negative words, the polarity score of positive negative words. And these actually information can be extracted from polarity lexicons, or emoticons, or exclamation question marks, and so on. Then we feed these features to a classification system. This is an example file of Weka. You may know that Weka is a machine learning tool which can do classification and regression and a few other tasks without any coding. Here we have 15 features. As you see here, we have 15 features, and the last feature is the class label. Each data entry includes a feature vector including these 15 features, and the last number is the class label. We feed this file including this many feature vectors to a classification system, and after training it, we use the trained system for estimating the polarity of test data. The result screenshot of Weka is given here. There are several methods that I'm not going to explain all of them, but only a few. The first metric that I'm going to explain is accuracy. Here the accuracy of this data is 58, which is relatively low due to some inconsistencies in data. But we don't care if it is too low, we just want to know what it is. This is the accuracy, which is the number of correctly classified data divided by the number of all data. If we use accuracy in isolation for each class, we will have precision. Precision is a kind of accuracy separately computed for each class. Recall is the number of correctly classified data entries for a specific class divided by the number of all data belonging to that class. And F measure is the harmonic mean of precision and recall. And the last thing that I'm going to explain is confusion matrix or contingency table. Here, as an example, 154 means that 154 data belong to class A, but it has been mistakenly classified as class B. But 54 data belong to class A, and this number of data have been correctly classified as class A, and so on. And this is the architecture of the system that I have proposed for sentiment analysis during my PhD. I get the documents, then I separate it into sentences, then I parse them, and I feed the parsed sentences the information extracted from the parser to the feature extraction box. In this box, we extract features by using some language issues, covering language issues and polarity lexicons. And after extracting handcrafted features, we feed them to the classification phase, in which sentence level, document level, and aspect level of sentiment analysis are accomplished. This is an example sentence given to the parser. Actually, I used E2 parser. The example sentence is bence hoş vakit geçirmek için seyredilebilir. This parser gives many useful information, such as a part of a speech tag, minor or major POS, morphology features, the root word, and some information related to dependency parse tree. As you see, these three last columns are related to dependency parse tree. I have used this dependency parse tree information for aspect level sentiment analysis, but the others probably for other the granularity levels. And this is the set of features that actually I have used for sentiment analysis of Turkish reviews. For example, the first group is the features extracted from polarity lexicons, namely Senti-Turknet or Sentiknet. Sentiknet is one of the best or the most accurate polarity lexicons in English. There are many other polarity lexicons, but I think Sentiknet, is one of the best ones. I have used many other features, such as the occurrence of emoticons, if the sentence is conditional, interrogative, negated, etc. And as results, I have obtained 79% accuracy for binary classification and 73% accuracy for ternary classification. I have also tested the feature groups in isolation. For example, the best feature group in isolation is feature 1 to feature 4, which are using the polarity lexicons. This accuracy is close to the final accuracy, the overall accuracy using all features. It means that using only polarity lexicons can have a high performance for sentiment analysis of reviews. The next group of methods is deep learning. This is the last group, then I will go over the conclusion. Deep learning methods, as you may know better than me, have emerged recently, and many people use deep learning for text classification, such as sentiment analysis and similar tasks. After finishing my PhD, I have also switched to deep learning, but during my PhD, for some reason, I didn't use deep learning, deep methods, deep neural networks. I used neural networks, but not deep ones. I use shallow ones. Anyway, in deep learning, usually people use word embeddings for representing the words. In word embedding methods, each word is represented by a vector of fixed size, and this fixed size can be 100, 200, or 300. And each vector, each item in the vector is a numerical value, actually, which is a float number, such as this one. Sample models of the word embedding, classic word embedding. I call it classic word embedding because I will mention that there are new word embedding methods which are more powerful than the older ones. The older ones, which are very well known also, are word-to-vec, glow, and fast text. But there is a big weakness or disadvantage on this word embedding method, and it is to be context insensitive. What I mean by context insensitive is that it assigns the same vector to different senses or meaning of the same word. For example, the word cold in English, it has several meanings or senses. I may say I feel cold in terms of weather. Okay, I may say uh, the I have a cold in terms of disease, or I may say he behaves coldly in terms of behavior. And these three word embedding models assign the same um, vector, actually the same vector, word embedding vector to all these meanings. But this problem has been solved in the newer models, which are mostly based on transformers such as BERT or ELMO. Another issue is that these word embedding vectors do not bear sentiment. And in one of the recent works, which is cited at the bottom of this slide, um, Tang et al., Tang and colleagues proposed a method for um, extracting sentiment-specific word embeddings. They use Twitter for extracting word embeddings, which also contain sentiment. Another method, actually a simple method in deep learning, which has been used mostly for text classification in DAN or deep averaging networks. These networks are based on feed-forward neural networks or multi-layer perceptrons. As input, they get word vectors, word embedding vectors, and they give the probability of belonging the given text to each one of the pre-specified classes as the output. This is the architecture of DAN. As I said, the sentence or text is given in terms of word embedding vectors to a model. Then the word embedding vectors are averaged on this model. Then the average is given to higher levels, which are feed-forward networks. At the end, a softmax function has been applied on the output, which assigns different probabilities to each to belonging the given text to each one of the predefined, pre-specified classes. The next method is recurrent neural networks, which is more popular than and has been widely used for text classification. These are appropriate for sequence modeling, and as you know, because the text can be supposed as a sequence, and each item or element in this sequence can be supposed as a word, these methods can process actually the text better than previous methods. Its disadvantage is that it fails to memorize the elements of long sequences which have been visited long time ago. In order to solve this problem, LSTMs or long short-term memory networks appeared. The advantage of this actually networks is that they have memory cell, while there was no memory cell in the previous methods, and this cell can be used for storing information. Also, topic RNN is a model based on recursive neural networks, which can capture long-range semantic dependencies or the local structure of word sequences in a text. Finally, I'm going to introduce transformers. As we already said, RNNs failed to model the longer contextual dependencies. This problem is a well-known problem, which is known as vanishing gradient problem. LSTMs appeared, which could process longer sequences, but still they worked sequentially. Then BiLSTMs appeared, which are based on LSTMs, but here the sequence or text is processed in two directions, from left to right and from right to left. But still, all processes were done sequentially. When transformers appeared as a revolution in NLP, they could see the whole sequence or text as a whole and process it in parallel. So parallel computing of attention scores of the words, which was obtained by attention mechanism in a text or sentence or document, was given as input to this architecture, and the estimated class for the text was given as the output. So the main difference of transformers with the previous methods was that it worked parallelly in terms of sequentially. Models which were based on transformers are BERT, GPT-2, XLNet, and so on. This guy here that I have shown here is BERT. His name is BERT, one of the most powerful models for text classification. Okay, at the end, as a conclusion, we can conclude that a sentiment analysis is very useful for companies and policymakers, or probably it's a must to be used for by companies and governments. Current approaches are far from ideal in sentiment analysis, either in English or other languages. Deep learning methods have been widely used for solving sentiment analysis related problems or even other problems of NLP. And the next issue is that there is a big gap between English and non-English languages. And there are many resources and research works in English, but there are much less work on non-English languages such as in Turkish. If you ask me what are the future challenges or future work for this topic, I would say sentiment analysis on idiomatic phrases can be a very interesting and challenging area. Sentiment analysis on informal languages such as Twitter, which is more difficult to process and analyze than the standard reviews, can be another area. And the last one, which is the most interesting one, and I'm working on it at the moment, is multitask learning. Multitask learning actually actually learns or trains the system with two tasks, and the output of one task can be used for improving the performance of the other task. In this area, in multitask learning, we use same data for both tasks, but we use different labels for each one of those tasks. For example, at the moment we are working on multitask learning of sentiment analysis and emotion analysis. So the two tasks should be similar to each other and they should have different labels, but they are applied on the same data, and the architecture or deep neural network is the same for both tasks. I think I'm done. Thank you very much. Sorry if it was too long or boring. I hope it was useful. If there is any question, I can answer at the moment, or